Welcome to the 24th lecture. We are studying stochastic processes and we are studying Markov processes under this subject right now. And today we will study a special type of Markov process we call the birth-death process. Let's see what type of process is this and what is the Markov chain associated with this birth-death kind of process, right? It's a special process, and the Markov chain that corresponds to this process has a unique property, and that is that all transitions lead only to lead only to the neighboring states, right? All transitions or the arrows that come out of a state, they land only on neighboring states. For example, given this example, out of the arrows emerging out of state 1 are landing on state 2, state 0 and state 1 itself. So you can consider any state, but the arrows coming out of that state will land only to itself or to its neighboring states, right? So here is an example of a birth death process, and the Markov chain is given. From state 0 we can only move to state 0 or state 1, and from state 1 we can only move to state 2 or state 0, or we can remain at state 1. Mainly queuing theory problems are addressed by this birth death process, right? Mathematically, there are two different types of probabilities associated with the transitions moving from one state to another. Probability that at next time interval state would be the next state from the next state would be BI. This is forward probability, or B stands for birth. Right, we move to the next state. And the probability that at very next time interval we move to one previous state, I minus one state. We call that the death probability, DI. Like we have this D1, these D1, D2, D3. And the birth probabilities in this example are B0, B1, B2, etc. So let's analyze steady state probabilities for this special type of Markov process which has this birth death property. And we can compute steady state probability because the chain that we are working with has only one RC, recurrent class, and the chain is also aperiodic. If a chain fulfills these two properties, it has only one recurrent class and that class is aperiodic, only then we can compute steady state probabilities. And we know that the recursion based formula is this. We have been studying this basic formula for the last few lectures, right? So given this chain, let's find the steady state probability for let's try to find the steady state probability for this first state. Let's call it let's pi 0. In order to find pi 0, the long-term probability or the steady state probability for this state, we know that the recursion based formula can be rewritten like this: pi naught, instead of pi j we have pi 0, instead of j we have 0, is from 0 to m. Why from 0 to m? Because in this chain we have states from 0 to m. 0 is the first state, m is the last. So the state space contains m plus 1 states starting from 0 going up to m. pkj, p sub kj, where j is 0, so pk0 pi k. Right. If we expand this summation, this is p00 pi 0 plus p10 pi 1. We have already worked with this formula in our last lectures, and if we solve it, keep on solving it, so we have pi 0 and pi 1, and finally we come up with this expression that pi 1 is p naught over d1 pi naught, where p naught is the first birth and d1 is the first death. Right, so we wrote the recursion based steady state probability formula for pi naught, but we have come up with an expression of pi 1 in terms of pi naught. Right, so this is actually, we have computed the long term probability of state number 1 in terms of state number 0. Right, so we call it pi 1, the long term or steady state probability of state number 1. So we started with state 0 and we came up with the long term probability or steady state probability of state 1 in terms of pi naught. Right, so now we can repeat the same for pi 1 for state number 1, and we will come up with an expression for pi 2. So this is the work I have done for you. Pi 1 is the same. I have rewritten the same recursion based formula once again, and then I have expanded this and have picked these pijs from the chain, from this chain, and I have put all these values. You can verify everything, and finally n, and we have also substituted the value of pi 1 from equation number 1. What is equation number 1? This is equation number 1, pi 1 written in terms of pi naught. So in this expression that we write for pi 1, we have pi 1, pi 1, pi naught, and pi 2 terms. Right, so in order to get pi 2 in terms of pi naught, we have to substitute pi 1, the value of pi 1 from this equation in terms of pi naught. So once we substitute these, we'll come up with pi 2 that can be written in terms of pi naught only. So substituting this will give us pi 2 in terms of pi naught. Right, so in equation number 1, we wrote pi 1 in terms of pi naught, and now we have written pi 2 in terms of pi naught. And in general, any steady state probability or long-term probability of any state I can be written as in terms of these product-based formulas from b0 to bi minus 1, d1 to di times pi naught. So one thing is missing here. This is all this would be multiplied with pi naught. Right. Then this concludes that for m plus 1 states in this state, in this chain, the steady state contains m plus 1 states, including 0. They are m plus 1 states. They are m plus 1 states. And we have only m equations. So if you want to solve for every variable from pi naught to pi m, we need one more equation. Mth equation is, we have m equation. Oh, this is not mth. In fact, this is m plus, we already have m equations. So one last equation that we need is m plus 1th equation. And that equation we already know is the normalization equation. This normalization equation gives us that all long-term, the sum of long-term probabilities or steady-state probabilities of all states from 0 to m is a 1. So this gives us m plus 1th equation. This is not mth equation. This is m plus 1th equation. We already have m equations. Now we have, including this equation number 4, now we have m plus 1 equations and m plus 1 variables. So now, and they all are linear equations. So we can solve them simultaneously to find the values of long-term probabilities for all states in the chain corresponding to the birth and death process. Right, that's all for today's lecture. And in the next lecture, we will keep on studying Markov processes. Thank you.